Hey everybody, so thanks for coming out to the talk. This is going off the rails on a crazy train. I'm just going to get started because we've got quite a bit of content here. So just a bit about who we are. I'm Tomek. I'm a senior security consultant at NCC Group. I used to be a Rails maker turned Rails breaker, SigDroid on Twitter, and this is Jeff.
Yeah, I'm Jeff Jarmoc. I'm also a senior security consultant at NCC Group. We're both from the U.S. division of NCC Group, from the Chicago area, as you could probably tell there.
Yeah, so NCC Group, headquartered in the UK, worldwide offices, software escrow, testing, domain services. Let's get into Rails. This is just a basic outline. We're going to quickly kind of go over Rails just in case people aren't too familiar with it. Then we're going to drop into authentication, which Jeff is going to talk about. And then I'm going to talk about authorization. We're also releasing a new tool called Boilerman today. So we're going to be giving a demo of that at the end. So let's talk about the structure of a Rails application. So this is the command that gets, when you run Rails new sample app, this is kind of the structure that starts to get generated. And there's a lot more files, but I'm only touching on the ones that are interesting here. So Rails is an MVC architecture. So what you'll see in the app directory is a directory for models, views, and controllers. So models are kind of the objects that get tied to your backend database. The views are kind of the presentation templates that your users are going to see, and the controllers kind of the logic and the glue that put those two pieces together. So one file that I want to mention here is the routes file, which is in the config directory. So this is pretty much like it's a DSL that maps URLs to controller actions. So we'll talk about that a little bit more later on. Then we have two files, the gem file. So that pretty much lists all of the gems in your Rails application or libraries. And then gemfile.lock is going to show you the actual specific versions of the gems that were installed or that the application is using. So this is useful if you're looking for a specific vulnerable version of a gem. You're going to tend to look into gemfile.lock to see what version they're using. So let's talk about the kind of Rails way. DHH released a blog post kind of talking about Rails is omakase. So that's kind of the notion of, kind of have a sushi chef, and he makes all the decisions for you and puts the menu together. He throws out the term a la carte software environments. Those are what frameworks tend to be. So you have all these components and pieces that you can put together yourself, and you have to kind of think about that configuration beforehand. So Rails has this notion of convention over configuration where it makes a lot of those decisions for you. So this is just a breakdown of what you're going to see in terms of the corresponding model view controller. So active record is kind of the glue for the ORM. It gives you objects that you can kind of call finder methods on. And this, by default, is going to give you a lot of SQL injection protection. In the parentheses, we have a link to railssqli.org, because there are a lot of ways that you can actually do that wrong and still have SQL injection in a Rails app. Action view is responsible for actually rendering the views that the users see. And again, you're getting a lot of default XSS protection here. And of course, they have methods available where you can output raw data, and so you still have the possibility of XSS, but you've got that protection by default. The action controller is going to be the controller classes that you'll have in your application. So you get things like CSRF protection right off the bat, and that's through this protect from forgery method that you'll see at the top of the application controller. So now Jeff's going to talk about authentication authorization.
Okay, so the point there is that out of the box, Rails gives us a lot of protection for common security problems. It's not perfect by any means, but usually the developer has to do something a little unusual and go out of their way to kind of shoot themselves in the foot security-wise. But one area that's a little bit different is authentication and authorization. There's a lot less capability out of the box in Rails to handle authentication and authorization, despite the fact that most significant applications are going to need this sort of functionality. So this is where we go off the rails a little bit, and the developers left up to their own devices to implement authentication and authorization. So one thing I want to make clear off the bat, authentication and authorization are two separate things. A lot of times I see people kind of mix them together into one term, but it helps to think of them as two discrete pieces of functionality. Authentication focusing on who is the user, just establishing their identity, improving their identity, and authorization then determining what actions they're allowed to perform. Within Rails, authentication is really only supported natively by HTTP basic and digest auth, which is probably not what you're looking for in most applications. Authorization, there's really no native facility. In both of these cases, there's some helper methods that can make it a little bit easier to build your own systems, but you really do have to do that. So building your own authentication system, there's two options. The first option is to roll your own, write your own system. So the risks here are that you're kind of reinventing the wheel. A lot of people have done authentication systems and learned a lot about them. So writing your own, you kind of have to relearn that whole body of knowledge and best practices. There's also a lot more to authentication than checking and storing passwords. And some of these are things that the developers might not consider when they're building their systems. And then the last point there is a plus. Since Rails 3.1, there's a function called hasSecurePassword that's a helper method that you can tie into your models. And we'll talk about this a lot more a little bit later on. But that can really make it a little bit easier to build your own system. The second option when it comes to authentication is to use a gem. So that's an off-the-shelf open source library that implements an authentication system within your application. So again, there's some pros and cons. The first point there is that vulnerabilities in gems tend to be pretty wide-reaching. If you have a popular gem that you're using and there's a vulnerability discovered in it, it may be more attractive to attackers because it's going to affect a larger number of applications rather than just your own. So for that reason, the second point there is that you have to really pay attention to your dependencies, track their life cycle, watch when they're releasing new updates and bug fixes, and adjust, in your applications, make sure that you're keeping on the front of that. And then integration is still tricky, even with an off-the-shelf gem. There's some work that you have to do to glue it to your application, and that can be a little bit difficult in some cases. But the benefits here are really big with off-the-shelf gems, and that's that the core code is generally pretty well vetted. There's a lot of people that look at it, that poke at it for security problems, and so for that reason, gems tend to encapsulate the whole past community experience, and there's a history of improvements and tweaks to make things better as we go that we benefit from. So let's look at some of the common authentication gems. At the top of the list is Devise. That's far and away the most popular authentication gem, and we're going to talk about it in pretty good detail here. It's built on something called Warden. That's a middleware layer that rides on top of Rack, which is the whole middleware layer of Rails. But it's really the one that you see most often, you're most likely to encounter in an actual application assessment. The second one worth mentioning is OmniAuth, and this is a multi-provider OAuth consumer. So it allows you to do third-party OAuth authentication against, say, Facebook or Google or something like that. Devise has some hooks that call back into OmniAuth, so you can actually integrate OmniAuth within Devise, which is kind of nice. It gives you the flexibility of having a database-backed authentication system built on Devise while still having the flexibility to use OmniAuth for OAuth. Doorkeeper is the third one we have here. That's a little bit different because it makes your application into an OAuth provider. So you can also then consume your own OAuth provider, but you can also publish it and allow other applications to authenticate against your system. And then AuthLogic is the last one we have listed here. It's a little bit different than the other ones. It has a kind of an unusual model where it blends sessions and authentication, whereas other systems usually put authentication on the user model. So it's a little bit different, and it's not that popular. I don't see AuthLogic a whole lot. There's all kinds of other gems available for authentication. But these are just the big ones, the ones that are most notable and are the ones that we see the most frequently. So let's talk about some of the arguments that we see people use when they're trying to support the idea of writing their own authentication systems. Up here we have a quote that comes from the Ruby on Rails tutorial. This is a really popular book that people use to learn Ruby development. It's freely available online on a website, and you could buy a paper copy of the book or put it on a Kindle or something if you prefer. But the parts here that are bolded are some of the sorts of things that I hear some of our clients say a lot of times when we're performing application assessments. The first bolded point there, authentication on most sites requires extensive customization. Modifying a third-party product is more work. And the last point, off-the-shelf systems can be black boxes, and they're scary for that reason. And I don't really agree with these points entirely. It does require some customization. I don't know that that's as true for authentication as it is for authorization. Usually authentication is pretty cookie cutter, but authorization you certainly need to account for the model of your app and the sorts of actions that it allows and how you've structured your permissions. Modifying a third-party product is more work. I don't know about that. When you account for all the little nuanced things that you need to get right in authentication systems, it's quite a bit more work than I think people realize. And then the point that off-the-shelf systems are black boxes, well, that's true of Rails itself, really. Unless you're the sort of person who's going to audit every line of Rails code and all of its dependencies, there's some degree of black box there, and that's in some ways a benefit. So while I agree that it's valuable to write your own systems just as kind of an educational exercise and to get an idea of how they work, I'm not sure that that's a really good idea in production. So I disagree a little bit with this point. So let's talk about, if we're going to write our own, how we might do that. And here we have an example of a really simple user class. The database schema in this case gives us two attributes. We have a name and a password digest, both of which are strings. We call this has secure password helper method that I mentioned before. And that gives us a really basic authentication system. Now, I don't mean basic auth in the terms of HTTP basic, but just a straightforward bare bones authentication function. So we get some convenience methods here. When we create our user, we provide the name, and we can see that the name exists in the schema, but we have this password and password confirmation value, and those don't actually exist in our database schema at all. Those are provided by the has secure password gem as convenience methods to set a password. So password confirmation there, if it's provided, must match the password. When those both exist, has secure password is going to use the bcrypt gem to store your password digest securely, as a bcrypt digest in that password digest string. So it does that all transparently for you, and you can just access that password setter. And then you save your object, and it returns true. The digests, as I mentioned, are stored in bcrypt, and that's a really strong password storage scheme. I wrote a long blog post a while ago about password storage because it's something that I continue to see people, provide bad advice about. So if you're interested in password storage in more depth, you might want to check that out. So another thing that we get from that has secure password helper is this authenticate method. We didn't define this anywhere in our model, but it's added by the helper. So this is pretty straightforward. If we call user authenticate and provide the wrong password, it just returns false. If we provide the correct password, it returns the user object itself. In Ruby, objects are true, so if you do an if on that, it's gonna validate as true. And then we get active record. That user model inherited from active record base. So we have all of active record's fancy database finders. So we can do something like this and do, the user class, find the user by name, call authenticate against it, and pass the password, and we get back the user object once authentication's passed. So that's a really straightforward authentication method. But there's a lot more that you need to do, as I've said before. There's things like session management, which Rails can help with. You may want some password complexity requirements. The big one, and one that we're going to talk about in a bit of detail, is how you handle lost and forgotten passwords, because that's kind of complicated and and easy to do wrong. And then depending on your application and its use cases, you might have things like API tokens, multi-factor, two-factor authentication, or OAuth that we touched on a little bit earlier. So let's talk about session management for a little bit. Session management, I'm sure you're all pretty familiar with the basics. It's just the idea of exchanging a credential for a token. In Rails and in most web applications, that's going to be a cookie that the user stores in their browser. They present that token on subsequent requests to identify themselves, and the application is responsible for invalidating that token at some point. And that's going to occur, when the user logs out of the application explicitly or when it times out. In Rails, there's a couple of different options for where we store session state and how we store that are kind of important to understand. So let's talk a little bit about encrypted cookie sessions. This is the default way that Rails handles sessions in recent versions. So we've got a sign-in screen here asking the user for their email and password. So the user comes and enters their email address. They provide their password, and they apparently shout it at the top of their lungs at the same time, so we all know what it is. The application looks up the user based on that email address, authenticates them with that password, and that's successful. So as a result, we create a session object on the server side. With encrypted cookie sessions, then, that session object is serialized and encrypted and passed to the user, and that's their actual cookie that they use for authentication. So when the user comes back to the application, they present this cookie. The application will decrypt it, deserialize it, and then recover the session object from it. Database sessions are a little bit different. We've got the same login flow, but now on the right, we've got a database on our server that's going to store our session state. So same deal, user provides their password, user's authenticated, session object is created in the database. There's also a random cookie that's created that's stored in that database as well and associated with that session object. That cookie is provided to the user. So with database sessions, on subsequent visits, the user provides their cookie, which is just this random value, and that's looked up in the database and the session object's retrieved. So there's some pros and cons to each of these approaches that we're going to talk about quick. As I mentioned, on database sessions, the user cookie is random, and on the encrypted cookie sessions, they're serialized session objects. So I've got italics here because I consider that a win for database sessions because there's a little bit less attack surface there. There's nothing that an attacker can really manipulate unless they can just guess a random value. When we talk about revocation, there's no maximum lifetime by default on Rails for session tokens on either. So we'll talk about that a little bit later. The big differences, though, are on database sessions, you can really only have one concurrent session because it's associated with the user's record in the database. Whereas cookie sessions, you can have an unlimited number of concurrent sessions. Depending on your use case, that might be a problem. If you're a banking application, you might not want a user to be able to log in concurrently from multiple machines, something like that. And then the big benefit really on database sessions is that you can revoke them simply by deleting the object from your database. With encrypted cookie sessions, you really can't do that. As long as there's not an expiry time, baked into the encrypted value, you really have no way of revoking that session token. So that's something that you really have to be a little bit careful with on encrypted cookie sessions. I talked a little bit about attack surface, but on database sessions, the only thing you can really do is steal that random value or enumerate it if it's not generated securely and random enough. On cookie sessions, you've got a lot more options. You've still got that enumeration, but you also have the possibility, at least, of cryptographic attacks. To be clear, I'm not really aware of any cryptographic attacks that are viable against current Rails, but it's definitely an attack surface that's exposed that isn't in database sessions. You've got likelihood of long and infinite-lived sessions because your session tokens are more likely to be the same, on subsequent visits. And then the encryption key exposure is a really big deal. If your encryption keys leak, then someone with knowledge of the encryption keys can create their own session objects arbitrarily, and your application will honor them. This kind of leads to an issue with deserialization. Some versions of Rails, depending on configuration, will use Marshall serialized cookies. which ties back to the whole XML deserialization vulns from a couple of years back. So given someone's encryption key, you can craft a malicious session object, get them to accept it, and get remote code execution on the server. And then the last thing to discuss here is the overhead. Database sessions, you have to do a query on every request because you've got to take that token, look it up in the database, and and retrieve the session object. Caching might help you there. If someone's visiting the site, frequently, it's likely to cache that result. On cookie sessions, you've got the whole process of validating the signature to ensure that cookie hasn't been tampered with. You've got to decrypt that value, and then you've got to deserialize that cookie. So this is where it's worth noting that database sessions are no longer supported out of the box by Rails. That functionality has been moved to a third-party gem. The reason that was given for that was performance, that on large applications, the process of hitting that database all the time is pretty, it's pretty significant. I think that's really only at the top end of the largest applications. So I'm kind of sad to see it not even an option in the base install of Rails. But there certainly is some performance overhead there. I'm just not sure that it's that significant compared to all the decryption and deserialization. But I really haven't done the math to work out in the wild numbers. So let's look at how these session types are configured. You've got your config initializer session store.rb, which stores the configuration for your session objects. This first setting here flags that we're using cookie store in this case, and that's the default now. And then your key is just the name of the cookie that's presented to the user. This expire after that's bold is important. That's not there by default, and if you don't have that in that configuration, your sessions aren't going to expire. So that's something that most applications are going to want to do. With some, in some reasonable lifetime, you want your sessions to expire. So that's a big thing to look for if you're assessing applications, to make sure that session tokens are expiring on a regular basis. If we wanted to set up active record store, that's the database backed cookies. We just have to change that cookie store setting there to active record store. We do need to have the active record store gem loaded, so that's going to have to be included in the gem file as well. Cookie sessions have a couple other options. In config secrets YAML, you set secret key base to some secret value, hopefully something long and random, and that becomes the encryption key that's used to encrypt your cookies. Now we need to be cautious. If you use secret token instead of secret key base, you don't end up with encrypted cookies at all. What you end up with in that case is just signed cookies. So it's just base 64, it's serialized base 64 encoded and signed. So the signing will prevent someone from tampering with it, but it doesn't prevent them from reading it. If they can base 64 decode text, they can see the contents of their session. So that could be an issue if you're storing anything sensitive in the session objects. You generally don't want to store full objects in sessions anyhow. But if you're doing something like that, a malicious user can read all that data. We have another initializer here in config initializer session store, and this tells us what serializer we're going to use for those cookies. Since Rails 4.1 and higher now use JSON as the serializer. Prior to 4.1, it used Marshall by default. As I mentioned, Marshall load was the vector for the XML deserialization vulns, and so that gives us code execution if we can encrypt a cookie. Hybrid is kind of interesting. In hybrid mode, what's going to happen is the application is going to provide the user JSON serialized cookies, but it's going to accept both JSON or Marshall serialized cookies. And so that's meant to be a backwards compatibility migration path as you're changing from Marshall to JSON cookies. I do see in a lot of cases where people will enable hybrid and deploy to production and then just leave it there in hybrid. So if you're black box testing the app, you might only see JSON serialized cookies. But if you actually craft and present a Marshall serialized cookie, it's honored. So you still have the remote code execution possibilities there with hybrid cookies. So that's definitely something to watch out for. You really only need to be in hybrid mode for the expiration length of your session cookies. So as long as you have the session timer configured that we talked about, in my example, it was 2 hours, I really only need to be in hybrid for that length of time, because after that point, I shouldn't see any more Marshall cookies ever, so I can go safely to JSON. Let's talk about lost and forgotten passwords. This is an area that a lot of applications have problems with, and so it's one of the areas that it's easier to overlook. You don't think about that functionality as much, but it's very often an Achilles heel. Some of the approaches I see people take are things like password hints, changing a password and then sending it via email to the user, so they have their plain text credentials in their email box for who knows how long. And then the idea of secret questions. So I like to call them Facebook questions, things that are searchable about the user, their mother's maiden name, the street they grew up on, or maybe their favorite food. Yeah, no laugh out of that, huh? Ozzy bit that off a bat, all right. Anyway, I don't really have any code examples to go along with this one, because it's really just the approaches that are flawed. So there's not so much of a specific pattern that you're looking for in code. It's just if you see these approaches, they're generally pretty weak. So let's talk about the good ways to do lost, forgotten password storage. And I like to see this process. Generate a random token. Be sure you're using a cryptographically secure pseudo-random number generator, so that there's enough entropy it can't be guessed. Store that token in the user object along with a timestamp of when it was created. Transmit it to the user out of band. Unfortunately, that's about the best we can do, is to email that token to them or send it over text message or something like that. We have to get it to them somehow. The user then visits the site with the token, usually by following a link to reset their password. The server then looks up the user object associated with that token, verifies that expiration policy, that token was created within a time that it's still allowed. So that prevents that token from being active forever if it's compromised from the user's mailbox. And then finally, change the password. And the last step here, and this is one that people forget a lot of times, delete the token after you've changed the password, or delete the token if the user successfully logs on and has an outstanding token. Once the user has access to their account, we don't want that token hanging out there, potentially allowing someone to recover their password. So let's talk a little bit about devise. I mentioned earlier on that this is the most popular authentication gem for Rails. So if you were to install it, you just put gem devise in your gem file. You run a couple of commands there. Generate devise install builds all of devise's views and moves some files around within your application to set it up. Rails generate devise user creates a user model that is backed by devise for authentication. If it doesn't exist, it's created. If you already have a user model, it's actually edited to include devise. The next files there are configuration related. So the initializer that I have in bold, this is where you have a lot of constants that govern how devise works. So you'll have things like your password complexity policy, your password reset expiration time, whether you want to send the email, send a confirmation email to the user, on certain events and things like that. There's also a lot of comments in here that sort of explain how devise works. So it's pretty close to having a manual. If you just read through all those comments, it explains all the various settings that you can tweak there and what they do. The next point there, you need to configure action mailer, and that's stored in environment RB. So if in a production environment, it's going to use production RB and so on. So action mailer is the component in Rails that allows applications to send emails. Since devise sends emails for things like password recovery, it needs to be configured to point to a legitimate mail server. Once you've done that, you run rake db migrate, and that will establish all the correct schema in your database and all that, so your database is ready for devise. So once you've done that, if you open up your user model, you're going to see something like this. So this is just a stub that devise created. So it's a it's just a class that inherits from active record. And then we've got some comments and devise with all these different modules. So devise has a modular architecture where you can turn different components off and on depending on what you want in your environment. But these are the ones you get by default that are in the bluish purple here. Database authenticatable is really the main module of devise. That's what gives you, an active record-backed authentication system. Registerable allows users to come to your site anonymously and create an account for themselves. So if you don't want anonymous people to be able to create accounts, you can just turn that off. Recoverable is the password reset module, and we're going to talk about that in a bit more detail. Rememberable gives you a little remember me box and so on. Trackable logs, IPs, and timestamps when users log in. Some of the ones that aren't enabled by default. Confirmable will send the user a confirmation email after they register before their account's active. Lockable locks out on failed login attempts. Omni-authable, I mentioned there, it provides some callbacks into Omni-auth if you want third-party authentication. If we look in our routes file in app-config routes.rb, we only see a single line added there, just devise for users. So that's a little bit opaque, but what this means is that we want to establish devise routes for our user model. So if we actually run rake routes, we're going to see the effect of that. So that single line causes all of these routes to be created. And these are all part of the various modules. So we have, sign in, sign out pages, password change pages, user registration, et cetera. And that's all, with just a couple of commands to install it. So now we've got devise working, but we need to integrate it into our application. So there's a couple of things that devise gives us that we're going to use to do that. The first is a controller filter. You're usually going to see this as a before action. It's called authenticate user, and it does what you would expect. It authenticates users. So you'll often see this put in the base application controller. Other controllers in Rails will inherit from there, and so that's going to require authentication for everything in your application. If you have a couple of pages where you need anonymous access, it's just a brochureware page or something. You can skip them in that controller. And Tomek will talk about controller filters in more detail in a little bit. The other things it gives us are these helper methods, user signed in, current user, and user session. They're pretty self-explanatory. User signed in just returns a Boolean of whether or not there's someone signed in. Current user, I've got bolded here because that's really the one you're going to see the most often. That returns the user's object. And so a lot of times that's going to be the base of further functionality in your application. So you'll see that all over the place. User session returns the session object associated with the user. So devise has a bit of a security history. This slide lists some past releases that had fixes that are related to security. Most of these are really pretty minor things, and it's really a good thing to see that there's ongoing security improvements. We benefit from this, especially if you look at things like email enumeration. That's really common, and you're going to see that in a lot of places. So it's good to know that they're catching and fixing these things, and as a user of devise, I benefit from that that community of people improving it. The two I have bolded there are a bit more interesting. They're now storing password reset tokens as HMAX, so they don't actually store the token value that they send to the user, which is kind of nice because if the database is compromised, someone can't recover password reset tokens and then reset accounts and gain access to them. So it's nice to protect those. The last one there in version 2.2.3, this fixes a type confusion vulnerability. This is probably the most significant vulnerability that devise has seen in recent years. I'm going to talk about this for the next couple of slides, but this was disclosed in February of 2013 by Jorn Shen of Phone Elite. He wrote a really good blog post outlining how this vulnerability works. But I'm going to go through it on a couple of slides because it's interesting to devise, and it's also has some applications outside devise that we'll talk about. So here's some pseudocode to how devise performs password resets. The actual code is spread across a number of modules. It's kind of hard to summarize on a single slide, but this is kind of the gist of it. The reset method first looks up the user who's asking for a reset based on their token that they provided in the parameters. If there's a user, so if that lookup succeeded, it then goes ahead and changes the user's password using the password and confirm password values that they provided. So again, those are going to have to match in order for that to succeed, but pretty straightforward. Where the problem comes from is actually MySQL's equality operators. So the example here, if we just do select foo from dual where 1 equals 1 string, it actually returns true, which is really confusing. The integer 1 compared to the string integer 1 string actually returns true, just because the leading digit is the same as the integer. So the types are off, and it confuses MySQL's equality. Similarly, if we compare 0 to any string that starts with an alpha character, it's going to return true. This is really bizarre behavior on MySQL's side, and it's really the core vulnerability here, but MySQL doesn't seem interested in fixing it, probably for compatibility reasons. So how can we exploit this in Rails? Well, there's the parameters hash that is a hash of what are usually strings that contain values of the user's supplied parameters. So in the examples there, parameter foo equals bar, fizz equals buzz, we get back params hash with keys foo and fizz, values bar and buzz. If we do the same thing passing in integers, the important point to note is that those are quoted, and so they're actually string representations of those integers, not integer values. So this isn't going to help us because we can't get integers through to the MySQL comparison. But there's some Rails magic that can help us here. XML and JSON bodies are parsed by Rails and are typecast according to the way those formats are normally parsed. XML is no longer supported out of the box in 4.0 and later, and that's partly in response to the YAML deserialization stuff that was a couple months before this vuln. JSON, however, is still supported. It doesn't give you quite the flexibility in the number of types that you can instantiate, but it gives you integers, so that's good enough for our purpose. So here's an example with an XML post. We set the content type appropriately, just submit valid XML. Notice on fizz, we're specifying a type of integer and sending the number 1. And now our params hash contains a key fizz with the value integer 1. So we've now got integers in Rails params. So what happens when we do something like this? Now this is the JSON version. It's a little bit different, but it's similar. We're posting with an application JSON content type. We've got user nested with password game over, confirmation password game over. And notice the reset token is 0, and that's not quoted. So that's going to be a JSON integer. So we end up with a params hash like this. Based on that pseudocode that I showed a couple of slides ago, we get a query that's user find by token with the actual integer 0, which active record is going to then use to build a query that looks something like select star from users where token equals 0. So the result of all that, it's going to reset the password of the first user where there's an outstanding token that begins with an alphabetic character. If you have a token that begins with an integer, you need to provide that integer for however many bytes deep the integer goes. So I wrote a Metasploit module a couple of years ago for this. The way the module works is on top of what I've showed you, it loops through and clears out all the outstanding tokens on the database. It can tell based on the response whether it successfully reset someone's password or not. Once it does that, it generates a token for a user that you provide. So you give it the username, and once it's cleared out all the tokens, it goes out and requests a password reset for them. It's then going to reset that password to a token of your choosing. Usually it'll work on the very first request, because if you send a 0, it's going to match anything that's alpha. If you get unlucky and your token happens to start with an integer, you have to match that integer. So you can configure how high you want the integers to go and how hard you want it to keep trying. The important thing to note is that the legitimate user is going to receive emails that they requested a password reset. And so depending on how savvy they are, that might tip them off to the fact that you've compromised their account. And then there's a little text of essentially what it looks like when it's running. So it's a cool module. It's an aux module because it doesn't drop shells, but you can oftentimes compromise administrator accounts if the application is vulnerable to this. But as I said, this is a couple of years old. It's patched in Devise now as of these versions. It's got an old CVE number. Thanks again to Jorn for disclosing this and publishing that post that detailed it so well. But the vulnerability affects more than just Devise. If you were paying attention to that description, you realize this is really a MySQL active record issue more so than a Devise issue. The Devise patch is actually just that, on that pseudocode, and I can maybe flip back there, they just add a to-string on the reset password token. So they just explicitly cast it to a string type, and then that keeps the query from being generated with that integer and causing the comparison. So Devise did fix this. Rails, let me skip ahead again. Okay, Rails also fixed it in 3.2.12. However, the 3.2 branch is a little bit interesting because they reverted the fix in 3.2.13. The Rails fix for this was that in Active Record, when they're building SQL queries, they look at the schema and look at the type of that object. And if it's a string, then they cast the object to a string and quote it, so it's safe. That's still the behavior in 4.2 and later, but 3.2 was only patched in 3.2.12. 3.2.13 reverts it, and later versions still allow those queries through Active Record. 4.2, however, looks up the type of the database, but you could still have a problem if you're using other Active Record finders that aren't type aware to do your lookups. So this example, you've got just a straight where clause. It's parameterized, so it's not SQL injectable, but you can get integers into it. So that's all you need for this vulnerability. So that's why we're talking about this. It's not just a Devise vuln. You see this in all kinds of homeworld systems that use tokens either for password resets or for APIs, things like that. So it's quite a bit more common than you might realize. And that Devise Metasploit module can pretty trivially be modified to work with other applications. And so now Tomek's going to talk about the authorization side of things. So have fun.
All right, so now that we have kind of an authenticated user, let's talk about authorization, which this is what can the user do now. More often than not, this tends to be tied to a concept of roles. And I like to break it down into two types. So you have vertical authorization, which you can think of as starting at the top, you have a site admin who has full access to the application, and then it kind of goes down and gets a bit more granular. You might have an organization admin with full access to their specific org. Then you have a regular user who might belong to an organization with limited read access and then unauthenticated, so they shouldn't have access to any organization's resources. And then the other type is horizontal authorization. So the idea here is that you have two different organizations. User 1 is an org 1, user 2 is an org 2, and they shouldn't be able to see each other's data. So what does this look like in Rails? More often than not, vertical authorization tends to be implemented in what are called before actions. These are also called before filters in older versions of Rails, but they're going to deprecate this in 5.1. I have trouble calling this before action, so if you hear me say before filter, I'm talking about the same thing here. But this is pretty much saying, we have a post controller here, and so for the first line there, we want to run the require admin before let's say in here we're passing the only option, so we're saying only run the require admin method before the create organization action. And the create organization action is a method inside of the post controller. And this can get more granular as you go down. In the last line we have except, so that's just saying require org user for every single action except public post, for example. And then we have, for horizontal authorization, this tends to be implemented through the use of associations. So Jeff kind of touched on the current user method that devise offers, which returns the user object. And then through this association chain, you can say, okay, let's get the organization for this user, and let's get all the posts that belong to that organization. So then when you're calling your finder methods on that object, you're only calling it on that specific subset of posts. So let's look into how controllers work. So first, you're going to start off with a route. This is going to be an example of a line that you'll see in that routes file. So it's pretty simple here. You've got just the HTTP method get here, the path that you want to expose inside of your application. So here we just have /posts, and we're pointing it to the post controller and the index action. So you can think of the controllers being the class, and again, the actions being methods within that class. So here's kind of an example, the post controller. There's our index action. This is just grabbing all of the posts in the application and stuffing it into an instance variable that's going to get rendered in the view. Note here the inheritance from application controller. That's going to kind of take us into the controller hierarchy. So this is an example of a pretty simple application controller. Of note here is kind of the part at the top here, the protect from forgery. That's going to give automatic CSRF protection to every single controller that is going to inherit from application controller. So that's more or less equivalent to saying before action, verify authenticity token. Underneath that, we have our own kind of custom method being called here, before action authorize user. And so that might be a method within the class as well that just checks that the user is properly authorized. So here we have a kind of look at the hierarchy. We have our post controller inheriting from application controller, which itself inherits from base and then metal and so on. And so the further you get up that hierarchy, you're obviously losing more and more functionality. And so we'll talk about that a little bit later. But in terms of the callbacks, we see before action, there's two other ones, and they're called around and after. But kind of due to the way authorization works, you tend to want to check authorization logic before any actual controller logic is run. And so we tend to more or less stick to before actions. And you'll see these in a few different flavors. This is going to be more or less kind of the most popular option here. But it's just going to be the different use of the flags. So here we have only and except. So we're kind of saying only run it on this list of actions. Except is the opposite of that, run it on every single action except the ones listed. You can also specify kind of conditional methods. So you can say run the authorized user check if this method call returns true, or unless this method call returns true. Another interesting one is the skip before action. So in the application controller, we have something like the verify authenticity token. So in the post controller, you wouldn't want to actually really do this, but you can say, okay, skip before action, verify authenticity token only for this subset. So we're going to come back to this a little bit later. And then you can even specify your own proc blocks, which are just like blocks of code that will get run. And so you can have pretty simple authorization logic stuffed in there. This is not going to be too common, but it does pop up sometimes. So for the authorization gems, two of the most popular are pundit and can, formerly can. And so can is more for the 3.2 branch of Rails, whereas can is for version 4 and up. They work pretty similarly, and that tends to be, you look up, so for pundit here, we're looking up a post object, and then we're calling authorize on that post object. And these are defined in policy classes. Can does something very similar through the use of ability classes. So you might see something like this. The difference here is that you're kind of specifying the ability. So here we're saying authorize read for the post object, and that'll automatically take the current logged in user in the background and check the authorization. It comes with some helper methods as well. So the underlying code is going to be, kind of makes use of these before actions and callbacks. So we're going to stick to those and kind of talk about what to be on the lookout for. I just want to preface these slides with, like, this isn't going to be a guaranteed vulnerability if you find code like this. They just tend to be patterns that when we see them, we tend to find vulnerabilities around them. So the first one is calling finder methods directly on model objects. And so what's happening here is that you're searching through the entire, like all of the posts in the database. And so you might not be limiting what kind of params email or params ID they're passing in. So we like to see the use of associations. So again, kind of going back to that last example, you're just cutting the subset of queryable posts to ones that actually belong to the currently logged in user. Another one is the use of whitelists. So here we're just saying, again, run authorized user on these actions. But you might think about the scenario where a developer comes back into this controller later on, adds their own controller action, and then forgets to add their action to this list. And so the authorized author is never going to get run on their new method. So we tend to like to see the use of except because that'll automatically include any new controller actions. And so when the developer comes in and tries to finish that controller action, they might get an error, and they'll have to look at this before action and think about whether or not they actually want to authorize the user. Because again, I mean, there's legitimate cases for that. Lightweight controllers. So going back to the application hierarchy a bit, you can actually, we'll see people inherit from the hierarchy above just application controller. So on the top portion here, we're doing application controller base. So again, we're losing CSRF protection, for example, or any of the kind of site-wide before actions that are implemented in the application. And you can go all the way down to action controller metal. This is as low level as you can get with the application still kind of working. But in metal, the callback module isn't even included, so you can't call before actions even if you wanted to. It would just throw an error saying that that method doesn't exist. So if you just see this in the post controller, inheriting from application controller, there's probably not going to be anything like too crazy around there, but you might see some skip before filters. Authorization logic and views. So here they might be currently checking the roles of the current user, but they're checking in the view and just more or less showing and hiding functionality in the application. So in this case, it's like an admin view. And so there's nothing stopping an attacker from just making a request directly to the controller. So you just have to be on the lookout to ensure that the application is also verifying permissions in the corresponding controllers. So skipping before actions, we kind of talked about this. Again, this doesn't always mean like a vulnerability, but you want to tend to pay special attention when developers use this and make sure that they actually intended it. You can think of a developer using a curl client to test their app, and they don't want to play around with CSRF tokens, so they might add that verify authenticity token to this skip before action, and then forget to remove it when they push their code. So yeah, just something to be on the lookout for. I want to just introduce scaffolding really quickly. So this is kind of the command that's being run at the top. So scaffold scripts is a nice way to get applications set up really quickly. So you'll see kind of these 5-minute Rails blog posts where you set up a full application in 5 minutes, and it makes heavy use of these scaffold generators, which will pretty much generate views, controllers, and models for you. And sometimes you'll see developers start with this and then kind of modify it to whatever they want. But they have to be careful because these scaffold generators generate some artifacts and make assumptions. So one of these files is the JBuilder file. So it'll take any of the kind of attributes of the model that you declared in the scaffold generator and automatically add them into a view. So JBuilder files are kind of the templates that will show the JSON response when you request like a .json format in the URL. And so this automatically adds every single attribute. And you might have some secret tokens in here that you might not want to show to the user. So just be aware of that. Another one is that it also automatically adds every attribute to the permit method for strong parameters. So strong parameters is a functionality that's built into Rails now to combat mass assignment, which you may have heard about. So that scaffold generator will automatically add all of those attributes to the permit method, so they're all mass assignable. So kind of looking at that, we want to introduce a new tool, which is called Boilerman. So if you kind of think about all the different controllers you can have in your application, and if you were going to be assessing a Rails app, you would have to be looking through not only all of those controllers, but then all of all the classes it inherits from, and see, what before actions are it declaring. So with this tool, this kind of dynamically resolves all the callbacks. It puts it into a nice list all in one place. It's going to be in browser. It hooks up to an existing application as a Rails engine. As a minimum requirement, you do need Rails console access. This is a dynamic analysis tool, so you might not have that all the time when you're testing Rails apps. But yeah, this has to be plugged in. And right now, there's a bit of a dependency on the Rails engine part, which I'm hoping to fix after this talk. But yeah, so I'm just going to demo this really quick here. Okay, so this is Rails Goat. This is an application that's created to be intentionally vulnerable. It's kind of released by OWASP. But if any of the stuff looks interesting to you that we talked about, you can kind of download this, run it locally, and then start breaking Rails applications. But this is a full application with a bunch of controllers, so I can add some login passwords, and this is all going to work here. But I've already got the Boilerman gem installed into this, so I should be able to just go to /Boilerman. And this is going to be the view that you see at first. So these are just what I'm calling filters, because I have no better name for it. So if anybody has one, but it's pretty much a set of filters that you can add that is going to filter this list here. So this is the meat of it. This is a breakdown of every controller, the actions on that controller, and the specific filters that are going to get run on that action. So if there are any people out there that have assessed Rails applications, you should already be kind of getting excited about this here. But speaking of that, just looking at the filters list here on the right, if we have the action breakdown, I don't know if anybody can see an action that's missing here that you should probably see on every single action in a Rails app. Kind of a quiz here. I talked about it earlier. It's declared in the application controller. Okay, it's going to be the verify authenticity token. So we should be seeing that for every single action here. So if I take a look in the application controller, I'm going to make a guess that it's probably not there or it's uncommented. And sure enough, in the application controller, we see this line here. It's commented out with some security guy keeps talking about sea surfing. Yeah. So if I uncomment this and kind of refresh the page here, we're going to see that we now see this verify authenticity token for every single action. So that's just one example. Just kind of a cursory look, you might be able to find something like this. The second one here is that Rails Goat has an API on the back end, so I'm going to use that as an example. So I'm going to add here just an API controller filter. So this is going to grab everything within the API namespace. So if we look here, we've got API v1 users controller. And just kind of looking at the filters list here, we see a valid API token filter, which looks interesting to me. I would maybe guess that this is some kind of authentication before action. And so if we look this up in the user's controller model, we'll see this valid API token and see that it does some kind of authentication logic here. And if I go into rake routes and grep for API, we're going to get a list of all the paths in the application that belong to the API. So here we've got the user's controller with the index action. So if I just go to this URL right now, we see HTTP token access denied. So we shouldn't be seeing anything if we're not authenticated into the application. If we go back to Boilerman and I kind of take this filter and say, okay, now show me all of the controller actions that aren't calling valid API token and in the API namespace. So if I add this as a filter here, we'll see that there's a controller here, the user's controller is here, but it's not listing any actions. This is a deliberate choice that I made because I don't want that controller to disappear. I want you to know that, yeah, the user's controller does exist, but all of its actions are calling that method, so you're not going to see anything here. We do see that the mobile controller, none of its action is calling that method. And so if we kind of go into the mobile controller code, we'll see we don't see a before filter or before action for it. And so if we look at the index action in our routes file, here we've got the mobile controller with the index action, so I'm just going to go to that right now. We'll see that we're already getting a different response here. And in this case, it's null, but we're not seeing that HTTP auth error. So if we go back to the index, we'll see that it's checking for this parameter class. And then it's pretty much calling classify and constantize on it, which turns it into an object. And then it's calling .all to return everything. So this is a quite dynamic endpoint here. So I should be able to just add a query string here and say class equals user. That'll call .all on the user and return all the users in the database. So yeah, this also plugs into Rails console. So here I have the Rails console if you don't want to use the actual web interface. So you'll have the actions available to you here. So here I'm just calling get action hash, and this is going to give you a nested hash of every controller, every action, and then the filters for that one. So you can write your own scripts around this, your own custom functionality. You can also specify the filters as an options into the hash. So here, this is equivalent to when I typed API in the actual web interface. So this is going to just give me all the controllers within API. But yeah, so that's going to be the end of the demo here.
Yeah, so the idea there is, you know, it's really cumbersome to review large Rails apps because you have to, if you're going through source, you've got to go through each and every controller, look at, you know, what filters are applied to it, as well as anything that it inherits from as far up as it goes to the chain, and, you know, keep track of all that in your head and watch for cases that don't make sense. But you can see from the demo how quick and easy it is to, you know, to sort through that information dynamically.
Yeah, and so I'm going to be pushing up the most recent version to Ruby gems, but it should just be gem install Boilerman or adding the gem to your gem file. I just want to make a kind of quick takeaway when I was developing this. Rails console is really powerful. I mean, it's providing a programmatic interface to a Rails application, so you have access to all of the models, all of the controllers. So you can kind of write your own scripts around that. I would definitely encourage you to ask for shell access if you're potentially doing an assessment for a client, or if you're just assessing some open source projects, and play around in the Rails console. You can kind of take a look at my code to see what I'm calling, but it's all just methods exposed within Rails on Rails objects. Future ideas, we're just kind of talking about this while at the con, but we're going to add a D3 visualization. You can imagine a matrix of filters on the y-axis, or on the x-axis, and then all the controller actions on the y, and then it should be really easy to spot what filters are being run where. Richo mentioned Pry in his Ruby talk. Pry is an awesome, awesome tool. It also lets you kind of dynamically get source and print the source for methods. And so in the cases of things like pundit or can, where you're calling authorized methods inside of a controller action, it'd be really useful for me to say something like, give me all the controller actions that don't call the authorized method. So yeah, it's a new tool. There's going to be bugs, so I encourage people to file bug reports, contact me, do whatever, and we'll get this thing kind of fleshed out here. So yeah, that's it. Any questions?
We have time for one or two questions. We're running a bit over.